Computational design and artificial intelligence are reshaping architecture, changing the way designers think, create, and solve complex challenges. As these technologies become increasingly integral to practice, understanding their potential is more important than ever. In today's episode of Friday Frames, architect Piyush Prajapati shares insights on algorithmic thinking, computational design, digital modeling, and the growing role of AI in shaping the future of architecture.
Everyone out there, very good morning. As Sonam said, my name is Piyush. I'm an architect and computational urban designer. And today I'll be talking about the role of AI, big data, and computational design in architecture. Okay, and I hope this session would help in bringing some fresh and new perspective towards design and architecture. So before we dig in deep into AI and big data, I would briefly like to discuss about the timeline of artificial intelligence in architecture. So in the year 1930, the era of modularity came into picture, where we saw a few amazing concepts in design. Modular system of anthropometry by Le Corbusier in the year 1945. But the Dartmouth research project was considered to be a founding event of artificial intelligence in architecture as a field. 1960 onwards, the era of computational design came. It emerged where we saw invention of sophisticated computer programs such as AutoCAD and CATIA by Frank Gehry. But MIT came up with the first ever AI-enabled chatterbox as well during that particular phase. And the era of parametricism came in the early 1990s, where we witnessed some of the amazing projects such as Vitra Fire Station, as you all know about it. It was designed by late Zaha Hadid. And the invention of Grasshopper as a designing tool came in the year 2007 as well. But now, to be honest, we have already passed through the era of parametricism, and we are currently in the period of artificial intelligence. Okay. So as one of the major breakthroughs in architecture of intelligence is the application of neural networks in designing. So basically neural networks are the set of algorithms that aims to draw a relationship from complex data set through the process by mimicking a human brain. Now to simplify it, neural network is a pattern recognition algorithm, which allows you to unlock your smartphone by your face ID or even an object detection. Now, the architects or designers, or let's say even students, are not really sure about how we can implement this idea of artificial intelligence into architecture, which thus brings us into three important questions. That is, what, why, and where of architecture of intelligence. So, AI is basically intelligence displayed by machines and softwares. Today, AI is all around us. If you own a smartphone, tablet, PC, or even a car, it is likely that it runs on some form of an AI, be it Siri, Cortana, or even Google Maps. Now let's understand why is this really important in architecture, or what do you think we can actually make out of it? So by knowing what we like, what we post online, what we buy, where we go, our smartphones, tablets, computers, through these complex algorithms, they empathically know us better than we know ourselves. Thus, the information gained can even be analyzed by an AI, or let's say an algorithm, to even automatically generate plans. Now, this is big. To give you an easier example, let's look at the Tesla cars. They all have AI pilots enabled in the car, and with every journey, the car uploads the data to the cloud server. And this data is mainly about the road congestion or the road openings or commute time, something which is very similar to Google Maps. So the next car that comes on the street has now the updated information on what routes to choose. Isn't this amazing? I mean, it makes the user experience for the next car owner better. And the way we architects can benefit from it is by analyzing these very data sets. You might come up with a very simple solution of a road congestion or a heavy traffic, where just by increasing the road width by 1 meter could solve the entire urban problem rather than by proposing an entirely new flyover. And their application is quite vast as well. by already knowing everything about us, such as our hobbies, likes, dislikes, activities, our friend, our yearly income. AI softwares, they can actually calculate the population growth. It can prioritize projects. It can categorize streets according to the usage and so on. And thus, it helps us to enable and predict a virtual future. And thus, upon gathering all the necessary information, the next crucial step is to actually create an algorithm that can understand all these parameters. Now, here is an interesting bit. With these design parameters, let's imagine if I have to design a housing complex, there are infinite number of design possibilities on how I can orient a building, where I should propose doors and windows, or let's say the fenestration, or what should be the ideal internal and external circulation. And doing it all by human mind, it would take not even days, weeks. It would possibly takes a couple of months in order to determine the different design options. And this is where the AI, or let's say the computational tools, come and helps us. Now, what computer intelligence would do is it would take all the listed design parameters, it would understand them, and it would compute to give you one from the million different possibilities. So now, instead of you or me brainstorming over millions of design possibilities or options, which would obviously take a huge amount of time, we would now have computationally derived solutions. Let's assume 5 to 6 different options, which would satisfy all the listed parameters. And as a designer and architect, it is your role to choose the right option tailored to your aesthetics. Now, this process is basically called as form finding. And this form obviously can then be tailored into numerous design languages as well, be it the housing complex done by Moses Shabde or the community housing done by Brack Angels. Now, here is another example of computationally driven floor plan where the aim is to increase the efficiency of the office layout. It is done by enhancing the spatial and the visual connectivity, by manipulating the internal wall, the partitions, and even the furniture layout as well. With this, I would like to show you a real-time post-concept design solution for one of the projects that I've been working on. And the project I'm going to talk about is Al Seef in Dubai. It is basically a mixed-use project for 1.8 kilometers on a stretch of 1.8 kilometers of land, having residences, retail, and commercial spaces. And the design is basically inspired from the traditional souk buildings of this region. These are some of the traditional buildings which you usually find in Gulf area, with having wind towers and niche courtyard spaces. And as the site is located next to the waterfront, one of the main criteria while designing the stretch was to enhance the public movement and the visual connectivity to appreciate the spaces and the waterfront promenade. Now, the animation that you see here is the computational analysis of the building height to achieve the best possible combination of the massing so that every building will have, if not the maximum, at least really great views to the waterfront promenade. Here are some of the professional shots of the building once the entire project was being constructed. The promenade and the quality of build form can be seen here. The traditional architecture style where each house and the building in the project has the story of its own. Moving forward, I would briefly like to talk about my research project as well, that is neural network public places. And I'm happy to say that this was exhibited at the Pompidou Center in Paris last year. And in this year, it was up for a virtual exhibition at Venice Biennale as well. One of the really great examples of integrating, let's say again, VR into the exhibition and how VR could be implemented into the exhibition spaces as well. So in this particular project, uh, the project basically aims at redefining the experience and the design of public places in the age of artificial intelligence. So the soul of the research project is based on big data. Now, you may know that the big data is considered as one of the biggest byproducts of 21st century. Almost everything that we do right from swiping cars to emailing, liking pictures on Instagram or Facebook, or even requesting directions from the Google Map. Big data today is acting as a bread and butter of artificial intelligence or AI algorithm and computational thinking. The term is even dominating in the field of design because it reveals human patterns. Now, when these data sets are read and analyzed in bulk, it reveals inner human sociology. For example, the data sets gathered from Google Maps would reveal how we humans interact with the spaces, the connectivity and the routes which we prefer to choose while navigating from or going from one point A to point B. Now, these data would help in designing better urban spaces. Now, the research even took a broader perspective of city to analyze it at the macro level. And upon overlaying the important urban fabrics such as the residential, commercial, the green spaces, choice map, which basically reveals the deeper finding of the city. The quality of any environment can be easily judged by mapping what you see, what you don't like seeing as well. And this particular slide basically talks about view at a particular point of the city and the areas that you can possibly see, and basically mapping it all together gives you a whole scenario or of a particular route that you're going, let's say from point A to point B, and what are your visual qualities that you come across while going from point A to point B. Now over here, the research highlights a particular area of the city that needs to be redesigned. In the initial process, the human movement is identified, followed by their visual preferences, as I was showing you in a previous slide. And then the big data and the AI algorithm then suggest a desired form tailored to this particular site. Now, obviously, these forms shouldn't be really confused with or to a built form. These are merely a form that has been generated by an AI algorithm. And again, it is the role of an architect or a designer to basically sculpt the aesthetics out of it. So here is the cross section with the spatial form suggested again by an artificial brain. And the form here has manipulated the build form in order to create or cater to the human needs and their preferences. Another visual from the computer vision, where it suggested that the form here is the right prototype of a flawless movement and which is being socially connected. Now, the great thing about creating these tools is once you have already established or coded your algorithm, the same can be applied anywhere, right? So all the research that I was showing you in the previous slides were mainly done for London, UK, and the same can be then reciprocated to any part of the world or any city as well. So what you see here is a social media analysis for the city in the obviously in Dubai. Now it reveals the areas and the parts of the city that are socially well connected and well active and can actually be considered as a hotspot in the city itself. And using this very understanding of human behavior, the next project that I'm going to talk about is the recent collaboration with Adidas for their upcoming stores in Dubai Airport Terminal 3. Since the terminals are usually a heavy loaded circulation area, there's a lot of thoroughfare, there's a lot of people moving from one gate to another gate. I use the big data to map the circulation movement of the passengers in order to construct a form that can be basically viewed from everywhere. So here's a small animation that basically shows you the red nodes and basically the red points that you see are here are the visual anchors. And the overall simulation of the analysis is shown here with the multiple anchor points. This is basically a space syntax analysis talking about or showing the visual connectivity and the human movement as well. And this being the entire process in an animation where what you see these black nodes or black points are, consider them as a humanoid, and once a person moves from one point to another point, what are the things or what are the visual qualities that you see can be mapped into any interior or exterior spaces as well. With this we came up with a different permutation combinations of forms, let's say, again, the form finding examples. And the final outcome was then built up at the site as well, which is there in this particular slide. So I hope this keynote did help you to get a fresh and new perspective towards the role of AI and big data in architecture. Thank you.